Hey guys, it's Miss Delcambre. Today is Tuesday, March 30th, and right now it is 3:30 on 3:30. Um, so give Google Slides a minute to load. So you will be needing your 17.3 notes. You need a pencil, a highlighter, scissors, glue to glue in your notes. What we did today was we did our Tuesday question, which is down here. How tall are you? We went over Builder 24. Whenever mock star questions, I picked up the homework, so please make sure you have your um, box plot work done and uploaded. And then we did our notes, our homework, and we had time to do Prodigy. And Prodigy is the questions on Prodigy go with your dot plot. It's actually called a line plot on there, which is the same sort of data that they're going to show you. So I'm going to stop sharing this screen and get to our notes. So when you go to your notes, you have 3 pages of notes. You're going to glue a page and then leave a blank page. You're going to glue a page and leave a blank page. So today's 3:30. This is my second attempt on this video. And we're going to talk about a statistical question. And a statistical question is a question that has many different or a variable answers, like a variety of answers that can go for this. So let's look at the situations below, these 5 situations, to see if it would yield a variable data. Your sister wants to know the typical weight of a cat. So the typical weight of a cat, just like a dog, they vary, meaning the breed. So think about it if I was looking at a breed, and I'm not going to say cat, I'm going to compare it to a dog. Like a Chihuahua's weight is different than a Lab's weight. A Cocker Spaniel's weight would be different than a Schnauzer's weight. So the typical weight of a cat you really can't get. There won't be one single answer. There would be a variety of answers. So this we would consider a variable. Give me a variable answer. How tall is your best friend? So if I went to my best friend Claire and I said, hey, how tall are you? She's not going to give me several different answers. She's going to give me one single answer. So we can say that this is not a variable, or not a variable. How far is your house from school? We're talking about distance here, not time, because time can change because something could happen, but we're talking about distance from your house to school will stay the same. That will be not a variable. I'm not going to have a variety of different answers there. Okay, question number 4 has, how much usually is a used car? Well, this all depends. So this is going to give me a variety of answers, because if it's an older car, may be worth less than a newer car. You may have to pay more for a newer used car than an older used car. The condition it is, the miles that it has on it, the make, the model. Okay. If it's been in a wreck, we came up with lots of different answers of why used cars aren't just one price, that it can be several prices. And finally, how many students are in line at lunch at 11:05? So if at 11:05 we stopped and we counted how many people were in the lunch line, we would get one answer. So this is not a variable. Now it could be a variable if we reworked it. How many students are in line for lunch today? So I would say, well, at one time during 6th grade lunch, it's this many kids. At 5th grade, it's this many kids. 6th grade, it's this many kids. So this could be a variable. You could change it, changing the word, but we're not changing the words, so it's not a variable. So a dot plot. A dot plot is a visual representation, just as a visual display, which each piece of the data is represented by a dot, hence dot plot, above a number line. A dot plot shows the frequency of each data set. So it's the frequency. So how many times? How many? Frequency. How many times does that data happen? So let's look here at our example. A baseball team's manager records a number of runs scored by a team in each game for several weeks. Use the data to make a dot plot. So the first thing they did was, before they even made a number line, they looked at the data and looked at it and said, well, it goes from 0 to 11, so my number line has to go from 0 to 11. So it went from 0 to 11. And then they proceeded and they drew a dot above the number line for each data value. So if you look, 1, they put a dot plot there, or dot there. 3, put a dot plot above 3, and so forth. And then they created their dot plot. If you think of it, it looks kind of like a bar graph, but with dots. Okay, so let's look here at our example 1. A different baseball team scores the following numbers of runs in the game for several weeks. Use the data to make the dot plot. Tell how many games the team played and identify the data value with the greatest frequency. So I'm just going to copy down these numbers down here on this number line. Even though some of them, this doesn't start with a 0, I'm still going to do it. 2, 4, 6, 8, 10. So even if my next question is analyze the 2, we can analyze the 2. So I have a 4. I put a dot over 4, cross it out. I have a dot 4, another 4, 6. And I'm going to do my best when I'm making my dot plot is to make them all kind of equal, like that they're all in the same line here. Okay. 2, 1 at 5, 1 at 3, 2 at 3. And do you see, like the 2 kind of goes, they're kind of on the same little row there. There's another 1 at 5, another 1 at 4, another 1 at 2. Okay. So tell how many games the team played. All right. So if we look, each dot represents a game played. Okay. So all I have to do is count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there were 14 games played. And I figure that out by just counting the dots. Or just count the numbers there. How many times? Identify the data values with the greatest frequency. So if we look, we can visually see that 4 runs is the greatest frequency. Because it occurred most. This was the most runs during that week. They scored mostly 4. Okay, that would be considered the mode. With dot plots, you can find mean, median, mode, and range, and we're going to talk more about that tomorrow. But here you can see that the mode would be 4. You can find what the range would be by taking the high and the low and subtracting it. So 6 minus 1 gives me a range of 5 runs. For that week, the range would be 5 runs. Okay? Now, on my next page here, okay, what we did was took some heights of students in our class. So I'm going to copy that data down. Heights of students. And this was, we measured them in inches. Okay, and I'm going to take the data from my homeroom class. So we had 160, 59, 62, 67, 68, 60, 63, another 60, 61, 58, 56, 65. So this is numeric data. Here's our data that we've collected for the heights of the students, and we're going to create a dot plot from it. So again, I'm going to start off with my number line. Okay, I look at my lowest number. Well, my lowest number is 56. So I'm going to start at 56. And then I'm going to go between and go by even numbers. 56 and then space. 58. 60. 62. 63. 60. This is supposed to be 64. 66. 68. Okay. All right. And now we're going to put a dot over each one. So I have one at 60. I have one at 59. One at 62. One at 67. One at 68. One at 60. One at 63. Another one at 60. One at 61. One at 58. One at 56. And one at 65. And doing it on line paper, I just lined it where they were all in the blue dot. Okay? So if we looked at this information, we can find the mode, we can find the median, and we can even find the range. We can also find the mean as well. We're just going to do that for tomorrow. So I can say that the mode, the one that occurred most often, was 60 inches. It occurred 3 times. 3 people are 5 foot in my classroom. The median, find the middle number. So if I look at this, they're already in an order. So I just cross off a high and a low each time. And my median is right here at 2. So it's 60 and 61. So 60 plus 61 gives me 121 divided by 2 gives me 60.5 inches. And then the range, the tallest person in my class is 68 inches, minus the shortest person in my class, which is, 56 inches, gives me a range of 12 inches. Okay? Now, let's go to our next page. Okay, you can describe the spread of data by identifying the least number and the greatest number values. You can also look for things called outliers. So the key word there is outliers. I'll use the word outlier a lot of times when we're dealing with this, and you need to know what this is. This is a number that's either much greater or much smaller than the rest of the data values. Basically, it's further away. So it's away from the rest. So like the outcast, okay? Like the untouchables. Think about, kind of relate this to your social studies units, okay? Those people were supposed to be far away from everybody else, could not be near people. So that's kind of like what your outliers are. So you can describe the center and the shape of the data set in terms of peaks, clusters, or symmetry. A symmetric distribution has approximately, so almost, the same amount of data values on each side of the center. Okay? So we have 2 graphs here. Let's look at the first graph. So the data values is spread from 3 to 7. So we call this our cluster. So from 3 to 7, this is what we call our cluster. They're kind of clustered around there. The peak means the tallest one, the one with the most dots, is your peak. So I can say my peak is at 5. I do not have any outliers. There's nothing. They're all kind of right there close together in that cluster. And then if I look at it, my data distribution from my center is almost symmetrical. So we can say that this would be considered symmetrical. Or symmetric, because it kind of looks almost the same on both sides from the center. Okay? Now let's look at this next piece of data. So, do you see this number that's way away from the rest? Okay, all this over here from 6 to 9 is your cluster. So everything's kind of clustered over here at 6 to 9. However, this lonely one is considered your outlier. Do you see how this piece of data is further away from the rest? Okay, this is also has a peak, one above everything else. So your peak would be 9. And would this be symmetrical? Is this going to be the same? So if I looked and I connect kind of like top of my dots, this would not be symmetrical. So from the center, it's not going to be the same. So this is not symmetrical. And we would actually call this something called left skewed, meaning it's more toward one side than the other. Okay, and that you have to think backwards because it's basically where the tail is. The tail is to the left, so it's skewed to the left. Okay, more my data is to the right, not to the left, so it would be considered left skewed. All right, so we're going to go over page 3 tomorrow. Okay, so that page 3 we're going to go over tomorrow. And I want to take a look at your homework. So let's go to your Google Classroom. And your homework tonight is interpreting line plots. So let's go down here to week 3. Okay, you're going to click on that, open with Cami. I'm going to try out some of these new tools on Screencast-5. Let's see. What do these stickers do? Oh, looky there. We can do stickers. Oops. Back, eraser, pen, mouse. There you go. Let's see about this mouse. Oh, looky there. Okay, so it says Tom was selling a box of chocolate candy for his school fundraiser. He plotted the number of boxes he sold in a line plot. Use the line plot to answer the questions, okay? So the first thing I would do is I would come over here, okay, maybe not. I would come over here and count how many of the boxes that you have for this day. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I click here and I type 10. Count here, 1, 2, 3, 4, 5, 6, 7, 8. So type 8 right there. And I would do that for all of them. Okay. So first question, how many boxes did he sell on day 3? You're going to type your answers over here. How many boxes did he sell? You're going to count and you're going to tell me that number and then boxes. Do not just put that number down. Tell me what it is. Tell me if it's boxes, days, day, what. Tell me what it is. Don't just put the number. Okay. Number 2, did he sell more boxes on day 7 or day 1? So you're going to look at that information. Day 7 or day 1. You're going to look at that. Which one did he sell more on? You're going to type day 7 or day 1. Okay. I had several students that had to go back and fix it because they were just putting numbers down. I want to know why. What do those numbers represent? Okay. All right. So that does it for me today. Get this done. You can log on to Prodigy. Prodigy has some line plot problems on there that you can work on also. All right. So take care, make good choices, and we'll see you later. Bye.